for a second. This is a picture taken on the 5th Avenue in New York City somewhere in the year 1900, literally in the year 1900. And I would challenge you to spot the automobile in the picture. There's only one. Now, why am I sharing this information? As human beings, we are known to be reluctant to change. We don't want to change. The way we do things is the good way, the right way. We don't need to change. But as it turns out, 13 years later, so in 1913, on the same 5th Avenue, it becomes almost impossible to spot the horse because everyone has a car. And as it turns out, as mankind, as a society, we actually love to embrace change to such a degree that anything that optimizes our quality of life, quality of services, is something that we're going to immediately welcome and embrace. Now, as software developers, I want you to put yourself in the same shoes as software developers. I've been a software developer for the past 20 years or so. I've always loved developing free-tier applications, the traditional apps. There's a front end, there's an API, there's some data. It works. And truth be told, we should call them traditional apps. But somehow, somewhere, marketing teams have rather decided to call them monoliths because it has this bad connotation. And advocates for microservices and whatnot, for containers especially, would say something along the lines of, monoliths are bad, but microservices are good. But the reality is that even though you may split the world in two pieces, monoliths versus microservices, evil versus bad, and so on and so forth, it has been so difficult for us to change as individuals. The world has always relied on monoliths, and it was fine so far. So something had to change for us to move away from monoliths. As software developers, for us, it's hard, almost impossible, to incrementally change our applications and our way we develop applications to make them microservices. And the reality is that when we start this complete plethora of many different smaller components, microservices, we find it difficult to debug them, to troubleshoot them, and so on and so forth, up until now. So for the next 40 minutes or so, I'll be your host. For those of you who don't know me, funny enough, I do see many familiar faces around. For those of you who don't know me, my name is Alex Mang. I'm a passionate software developer. Microsoft calls me a regional director, which is the funniest title ever. I got to tell you this story. So Microsoft Regional Director. I do not work for Microsoft. I do not own or represent a region. And my wife knows I don't direct anything. Certainly not her. And I'm also a Microsoft Most Valuable Professional on the Azure work category, which is also a fun thing, because Azure as a product is an American product. So if you have any doubts, you should call it Azure, not part of my British Azure, and certainly not Azure or Azure, as some people call it. And certainly not how they call it back in my hometown, Azure, which is very bad. Don't do that. OK, so this is going to be about DAPR, Distributed Application Runtime. Now, I want you to take a close look at this slide for a second. The definition of DAPR goes along the lines of an event-driven, portable runtime for building microservices on the cloud and edge. You can't even imagine how difficult it has been for the teams themselves to come up with all of these very particularly chosen words, because it literally depicts the fact that DAPR, as a technology, runs on this very sharp razor in between two worlds. The worlds where it is a framework which tells you what you should do, how you should implement it, and so on and so forth, versus the worlds of prescriptions, where it's up to you to decide whether you want to use it or not. And in my opinion, and I strongly believe that DAPR has managed for us developers to create this fantastic tech where you are able to build event-driven, pretty much like serverless implementations where you have binders and whatnot, applications, which are fully portable because they can run anywhere and you can develop them in any application you'd like. Go, Python, JavaScript, Node.js, Java, hopefully .NET, because the other ones are nonsense, right? Right? There we go. And you develop microservices with them, both on your premises, on somebody's cloud, on somebody's computer, or on the edge. Edge is usually another marketing term. Edge is a reference towards the location. The reference location is the cloud. Edge is anywhere outside the cloud, in your on-prem, on your Raspberry Pi. And come to think of it, a single application running everywhere around the world, achieving global scalability, you see why I see this as an automobile 100 years ago versus a horse, which would be fantastic, but would only take you so far? I find this to be the revolution in the industry and in the way we are going to develop apps. And bear with me, I'm going to explain you why. So when we write microservices, one of the most challenging things to do is try to be pure microservices architecture based and say we don't have any HTTP chaining, we don't have any kind of communication across our services, but there's always exceptions, because the exceptions makes for perfection, if you ask me. And sometimes you need to call from one microservice to the other. But how do you do that so that you don't have a connection string, so that you don't have a host name, so that you don't have an IP address or a port or anything like that? Well, for the Kubernetes people here in the room, you're going to be like, yeah, service meshes, it's easy. But you know what? That's fantastic for Kubernetes, or Kubernetes, whatever you want to call it. It's another debate, GIF or GIF. But here's the thing. The reality at the end of the day is that this technology should work for everyone, everywhere, any they would choose, any cloud stack, any cloud, any vendor. And DAPR fixes that. In this diagram, the way the things work is that DAPR as a runtime will work pretty much like a sidecar in Kubernetes or a self-hosted process running alongside your application. So remember when I showed you this logo? The logo has been particularly chosen to represent a butler, because DAPR is, at the end of the day, a butler or a concierge, where effectively you'd go to and say, hey, you know what? I want to talk, I'm service A, I want to talk to service B. And the butler will figure it out. Have you ever seen that movie called Hotel Budapest with the network of concierges around the world in all of the hotels around the world? It's pretty much the same thing. I want to talk to service B, you figure it out. I have no idea where they sit. I have no idea what room they have. I have no idea what port they listen to. You figure it out for me. Let me show you how this works in code. So the first thing I will do, this is a super basic, the template-based ASP.NET Core web application based on .NET Core 3.0. Super basic, nothing fancy about it, right? So you start in your startup method, you have your configure services. I'm not configuring any services, and they're using that approach where rather than using MVC, I'm directly mapping all my endpoints with my guests and my posts to some various methods. So it should be super easy to understand, right? When I want to retrieve a balance from a microservice, it's going to call this method and run this particular body here. When I want to run my deposit, it's going to do a similar thing. When I do my withdrawal, it's going to do a similar thing. There's one thing to point out, though. How many lines of code did I write for DAPR? 0. In fact, let me show you the CS proj file. I don't even have a reference to the DAPR project. And yet, here's what I'm going to do. Let me open up this guy. I'm going to open up a terminal, and I will F8 this command over here so that I'm immediately running this in my integrated terminal. If I can find that key. There we go. So what I'm doing here is rather than running simply .NET, I'm going to tell DAPR to run my application. I'm going to call it demo1, listen on port 5000 for the application, and hook up on port 3500 from the DAPR's perspective. So I'm initializing DAPR, and DAPR will simply call .NET run on my behalf. Now here's the catch. I'm going to open up this HTTP file. If you're not familiar with REST client, this is a fantastic extension available in Visual Studio Code. It allows you to not leave your environment and directly work within your environment with your HTTP requests. You don't have to fiddle with Fiddler or Postman or anything like that. So I could definitely call my local host 5000. It works. I'm calling my balance method. But I could also rather, instead of calling my method directly, call DAPR and say, hey, DAPR, I want you to invoke my demo1, which is the application I just created, and call a method on it, which is the balance method. You know the cool thing with that? The balance method actually is not part of the endpoints that you're seeing here. It actually looks at your code and determines, even though this is a private method, this is something that your service should be able to talk to. So I'm going to call that method for you. So when I call this guy, I'm going to get, oh, sorry about that. I'm going to get back my reply from the balance method instead. And I can do pretty much the same thing over here with calling the withdrawal method, sending over a payload, or calling the deposit method, sending over a payload. How cool is that? I'm just wrapping and completely abstracting my application in front of a butler, which will take care of all the service invocation I'm ever interested in. Now bear with me, because I want to show you something even better than this. So I'll stop the app. I'll stop DAPR here. There we go. And let me jump right over to our next demo. So in this second demo that I will show you now, you'll see pretty much the same application, but with some changes. Let's go through them. So first and foremost, you'll see here that even though the configuration method looks pretty much the same, I've done some changes in my configure services method instead. The first thing I'm doing is I'm calling this extension called add DAPR client. This allows me to communicate with all the components DAPR has. Like, do you need statefulness? Do you need to have pubs up? Do you need to have some sort of a service invocation method? I'm here for you. Let me just add this client, and I'll dependency inject everything for your demands. This is what the extension method does. And additionally, I'm also adding a singleton for my JSON serialization option, because I'm going to work with a lot with JSON. So here's what's going on. First and foremost, let's go to the balance method. When I will call balance, I will go along the lines of saying, hey, can I please get the DAPR client back, which is responsible of state? So bear with me. I'm not invoking any databases. I'm not working with any caches. I'm not working with any directories or anything like that. DAPR will do that for me instead. And the cool thing with that is that I'm going to read my request route values and my queries and whatnot, and then I'm simply going to say on the client, just get me the account. The account is a method a class I created, pretty simple, right here. 2 properties, here's an identifier, here's the balance that you have right now in your account, and I have a similar thing with the transaction. Here's your account that you're transacting to or from, and here's the amount that you're transacting with. Now here's the catch. And I go back to my startup method, I'm going to read that account information, and if there's no account, I'm going to return a 404. Otherwise, I'm simply going to say what the body and the response of that is. OK, cool. So let's open up this PowerShell again. Let's run the application with DAPR. DAPR is up and running now. And let's open the taste HTTP file. So once again, now I will withdraw. And rather than seeing that, hey, you just called withdraw, I will now see the balance of my account, -10. And I can withdraw some further, and I'm going to withdraw some additional information and money and whatnot. Now here's the catch. How does this actually work? Where is that information stored? Is it in DAPR? Well, you'd be happy to know that it is not in DAPR. It is actually wherever your operator wants it to be, which means that the abstraction level that you're getting as a developer goes up to a degree where you say, I want this data to be persisted. But it's up to your DevOps to figure out whether they want to use Redis, they want to use Cosmos DB, they want to use God knows what other technology in the world. Because the abstraction is not something you as a developer should be worrying, and the technology choice of your DevOps should not enforce you as a developer to rewrite your app. So all of that binding technology that everyone is craving for in the serverless world is given to you for granted without actually using a fully plain, out-of-the-box native serverless technology. This is a very basic ASP.NET app, which runs on my own machine, running on Kester web server. How cool is that? Now, look, truth be told, this was quite a basic demo. Based in comparison to this diagram right here, what I did is that I invoked my runtime, I had my service, and I used the CLI, a command line interface, to talk to my runtime. So let's take it up a notch. What I'm going to do next, once I stop my application right here, there we go, is that, you know what, actually, let's leave it running. And I'll open up another Visual Studio window. And in this Visual Studio, I will open up a client. So in my folder right here, I will have a super straightforward and comprehensible, easy comprehensible application, which is going to be my client for my service. So the way this guy works is that rather than having any kind of magic strings, application settings, where it would say something like, hey, application A or service A runs on localhost 5000 and requires these parameters, blah, 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 I don't need anything like that. Instead, I'm simply going to say something along the lines of, I need a client which is going to work over HTTP. You can choose gRPC, or you can write your own client with your own tag. If you want to use named pipelines or shared memory or anything like that, it's up to you. You can do it. And once you have that, you're simply going to say, so on that client, I want to call this service called demo2 with a method called deposit, and I want to add some money to it. And let's do that every second, because this is a salary, right? Wouldn't it be cool if we would be paid man second rather than man hour? That'd be fantastic, man. OK, so let's do this. Quite simple. .NET run, hit enter. Let's get it to run. I'll just give it, oh, there we go. I already got myself a salary. Good job, a second salary. So if I go back here and send my request now, you'll see how this actually started adding salaries of 100, of course, because it's good. So what I just did here is that I have a completely isolated application having no information whatsoever about another application, calling it and doing service invocation. The basic thing that you would require when you start developing microservices. In my opinion, it's super cool, and I love it. Now, let's get further with this. Let me show you something that is super important when you start doing applications like these, microservices. So I'll open up demo 4 for this. So, as demo 4 suggests, probably and hopefully, I'm going to now use cloud events. Who has ever heard of cloud events? Ever heard of event grid, eventing systems? So cloud events is yet another extension in DAPR that I can use, which will allow me, as a developer, to get messages and events, pops up. I'm not invoking any kind of crazy technology, writing any single line of boilerplate code in my app. Instead, I'm simply going to say, use events, and you know these methods? Let's add a topic to them. So they start listening. Whenever somebody sends a message to deposit or to withdraw, fantastic. I'm going to do that instead. So now I can have asynchronous communication with no HTTP chaining, nothing like that whatsoever, pretty much straight off the box. And from my methods perspective, it's exactly the same thing. They still work by using an HTTP context in the parameter. They still work by returning a task or a task of an async of an action result or whatever you'd require here to have had you had an MVC application instead. So let's start by running this application as well. So the way I do that, once again, I'll hit F5, F8 here. The integrated terminal is ready now. There were some messages. Let's ignore them, because we're developers. They're just warnings. Never do that. And now I'm going to publish a, you know what, this is actually not going to work, because my terminal right now is stuck by listening into that process. So rather, let's do this, and let's publish my method from here. So what I'm doing now is that rather than using an HTTP client, I'm using a pub/sub, no connection could be made. Demo gods are not on my side, apparently. I should have sacrificed the virtual machine in Azure, because it's Saturday. You know what? Let's try that one more time. I'm going to kill this guy. Application succeed. OK. What does it say here? 3202. Oh, I know what's going on. You see what port I'm listening to? I'm actually listening on 3503, 3502. This is a run application ID demo pub/sub. So this is going to happen in production, because remember, this is 0.4.1. So this is literally a bit of preview. So what I can do is I can debug it with you on stage right now. So I just stopped my application, and yet I see that there is indeed an application listening on 3502. That's fantastic. No problem there. You know why? Because I'm not going to care, because that apparently is an application that should be stopped. I guess a process hung or something like that. So let's stop this guy. Oh, do allow me to increase the zoom factor here. Demo 4. OK, failed to stop. Well, what do you do in those cases? You restart. I'm not going to restart, though. Here's what I'm going to do instead. I'll open up the launch settings. I'm going to make sure that the application is not listening on whatever this guy thinks it is listening on. So this was application port 5002. This is going to be 5003. Let's make it 5005, just to make sure, right? Let's go over here instead. Let's say application is listening on 5005. That's cool. Let's open up. This was already a different port, so that should be fine. I'll run the application one more time. Fingers crossed. Hopefully this will work. Fantastic. It's going to be amazing, I'm telling you. It picked up some messages, apparently, from the pipeline. And now I will move over to this window instead. Let's do it like this. And now F8 this guy. Oh no, wrong window. F8. So what's happening here, let me explain, is that this method is actually going through, but this application running on DAPR is also listening to the same messages, pops up, so multiple subscribers, and this command right here from the CLI is telling me, hey, you know what? There is one service who apparently cannot pick up your message. And DAPR knows about it. It runs with your application alongside. But for whatever reason, that particular butler from the application called demo4 cannot be invoked. So this effectively means that I'm actually pushing over a message to two applications at this point. One shouldn't be running and the other one is. And one is picking up the message, but the other one isn't. Which effectively proves pops up. So even though, you know what, this was how I wanted it to be. Of course. Joke left aside, hopefully this was clear enough and what happened here. Now, it is true, and be warned, even though Microsoft is trying to actively push people to use this in production, it is still a technology that is used in production right now by several companies, but things like these can happen. OK, I'm going to stop this demo, and I will show you another cool thing instead. So how many of you have heard about actors? Raise of hands. Actors, actor proxy, virtual actor proxy patterns, stuff like that. OK, cool. So for the rest of the room, the whole purpose of an actor is those scenarios where you have a business logic, where you want to isolate the data, you have a variable rate of the duration of your business logic. Think of a shopping cart. When you have a shopping cart microservice, there's two approaches. There's the cheap e-commerce website approach, which has a database with everyone's shopping cart, and you're going to continuously query on a large database which is indexed, and you're going to figure out, hey, why did Alex want to buy? Because there's this where predicate which says where customers equals Alex, and here's your shopping cart. But there's the other approach where you're using an actor, and every shopping cart would be an actor, meaning that Alex will have its own instance of an application running with a shopping cart business logic. You can check out, you can cancel, you can remove items. That's my business logic, free actions. And with my data, so that I don't have to query across my data over and over and over again. And that's pretty useful, because now I can ditch my indexes. I don't have to worry about opening up yet another connection, about index fragmentation, and so on and so forth. Right? So decoupled, isolated data with small components which have a variable request rate. Let me show you how cool and easy it is to write an actor when you use DAPR. So what I have here are effectively several folders. This one can be thought of, my iDemo actor can be thought of as some sort of a contract. This is a contract, this is what the actor does. Let's open it up. So in this window right here, you'll see that my iDemo actor, which is my interface inheriting an iActor from DAPR, will be able to save some data, get some data, throw some exceptions, because you want to test what happens when your actor throws an exception. Does the actor proxy or invocator know about that, and so on and so forth? You want to test sending some data over or not sending some data over to your actor, but simply talking to it. Maybe you need some sort of a health state or whatnot. You want to call a reminder. This is pretty cool. A reminder meaning, hey, actor, here's something for you to do. When you're done, remind me about it. That's pretty interesting, right? You want to unregister a reminder, register a timer saying, hey, let's start doing this every 5 seconds, right? There's a lot of scenarios for that. You have an actor which frequently has to update and validate. Think of airline tickets. You only have so many minutes up until we are going to kill your session. If you were running over a single monolithic database to query how many people have started the session, is it time to kill a session right now, that would literally take, because of a single business logic, a lot of resources and power consumption from your database workload. You don't want that. For an actor, it's super basic, because it's only going to run a single iteration within a single given process. And then unregisters the timer as well. Now, how do I use it? Well, first and foremost, I have here my demo actor. Let's open up this guy instead. So in my iDemo actor, I'll have my startup CS file. And inside my startup CS, just carefully look at it for a second. Do you see any special DAPR thing over here anywhere? Configure services, configure. Doesn't look like it, does it? And in fact, it doesn't look like I'm adding any MVC endpoints, any endpoints routing or anything like that. This is probably, in my opinion, it is probably the lightweightest application type that you could ever create. And the cool thing with it is that it almost has no entry points, meaning that its attack surface area is limited, almost inexistent. How cool is that? Think about it for a second. Now, I do, however, have an actor. My actor is right here. Demo Actor CAS contains all my actor data. What I have here is an inheritance of my actor-based class coming from DAPR, the interface, which is the contract I'm implementing, and the remindable, which is yet another interface from DAPR saying that this guy can run all by itself as almost like a hosted service or a background service having its own business logic. So when you go through this logic, it saves your data, it gets your data, and so on and so forth. Let me show you how cool it is to actually use this guy. So the first thing I will do, let me open up this, and let's open up an integrated terminal first and foremost. I'm in the wrong folder, so demo actor. Yeah, there we go. And now let's F8 this guy. So this will start my actor. And my actor is now running, hopefully. Demo gods, please be on my side. The next thing I will do here is that I will open another folder in the same actor, but I will open up a client. Let me show you how the client looks like. So this is going to be a console application again, where I'm invoking and using all the capabilities of my application. I'm using the virtual actor proxy but in its entire beauty. So here's some data, and then I'm creating an instance of an actor based on an actor identifier. This is coming from DAPR, no single line of code I wrote myself. This is going to be the index that is creating the context of an actor. Like in the case of the shopping cart example I gave you earlier, it would be like my identifier of my user, myself, right? It's going to be actor ID ABC. Fantastic. Now, I will first create an actor of type iDemoActor. It's going to get an identifier from here, and it will be of type demoActor. The type itself, believe it or not, is actually this class name, and that's it. How cool is that? Now, as I will go through this data, and let's actually start it, I will debug this guy. I will use every method that is available to me to invoke that actor. Hence the reason for why I'm using now 2 Windowses. I want you to see also the logs and everything that is available here. So there we go. Let's do it like this. I'm going to F10, and we'll start by creating the actor proxy and saving some data. And we just communicated from a fully isolated process with the other one and told that process, here's some data for you to store. And it also saved that data. Let's go further. Now I'm telling it, hey, you know what? Let's retrieve some data. And I just got some data back. Now I'm telling it, hey, let's call that actor by simply not sending any arguments. This is part of the business logic I wrote in my contract. I'm calling that method. Now let's try to throw an exception. Pay attention to this one. I'm throwing an exception by calling the actor, which in its implementation inside here, let's go quickly over there, should have a method which is called, where is that guy? Throw an exception. So it does this. This is a process all by itself. It's isolated. In a normal world, this would kill my application unless I would have unhandled exception handlers and whatnot. But because I'm running my application with the sidecar of DAPR, DAPR will make sure that that exception will be caught, and this guy will know about it. So let's test it. So there I go. I just called an exception. The exception was received. The request was retrieved, even though I didn't have any MVC endpoints. And even more so, I will have now an exception of type actor method invocation exception coming from DAPR telling me, hey, you know what? Here's the exception that got thrown. And I have all the properties which are necessary to me as a developer to get further information from that DAPR information, the runtime, the bottler. So all that communication chaos, which normally would exist if you would not have such a technology, is now given to you, pretty much for free, if you ask me, because there's no price to pay, literally, for performance, for security. In fact, I would argue that it actually, to some degree, improves your security with some caveats, but we're going to get to that. And now over here, I'm invoking my methods. Rather than using an HTTP method, I'm simply going to tell it, hey, DAPR, you have some methods in this actor. Please, butler, call that butler and tell it to run those methods for me. And you can do that instead, rather than using HTTP. So I'm going to invoke test no argument. I'm going to invoke save data, which are all methods. So I'm almost doing object-oriented programming by using distributed services. This is unheard of, if you ask me as a software developer. Now, let's go further. Let's register a timer. This is effectively going to say my actor, my DAPR actually, that my actor should be invoked every few seconds. The code is written inside the actor, and DAPR is picking up that information and running the business logic. And you can see how the logs in my actor side, on the left-hand side of the screen, are going to currently be updated based on the information that my timer has generated. Let's register a reminder. The reminder is effectively going to say something along the lines of, hey, you know what? I want you to send this data and remind me about it after a while. So what I'm going to do here is that I will delay my client, and then I will retrieve the information that was persisted in the state of the actor at the given point in time when that reminder was initially set. So when I retrieve this information, I'm going to get back my data whenever that information was set, several seconds ago. I can then register the timer because obviously I want to start my stop process, and I will also register my reminders. It's so easy. It's mind-boggling and mind-blowing how easy it is to use distributed services using a technology such as this one. Now, you know what? It does have, however, some SDKs that you would normally have to install and work with them. In a fantastic ideal world, you just take a full plain Windows or Mac machine, you start it up, and there's nothing to get installed. For those of you at the NPM, you know at least in NPM, you download first the entire internet on your machine, and then you start developing. Now, here's the catch. There is a fantastic functionality that I want to show you in Visual Studio Code, which regretfully, if you ask me, people don't know of. So what I'm going to do here is that I will open up one of these DAPR demos folders that I have. And the functionality I'm referring to is called dev containers. How many of you have heard of dev containers in Visual Studio Code? You know what I mean? This is exactly what I'm saying. People don't know about this. So bear with me. I'm going to open up Visual Studio Code. I will open up, say, either of these folders. It doesn't really matter. You see that folder right there called .dev? I realize that this is probably way too small. .dev container, I'll delete that guy. I never did this before. I live dangerously now. I will open the folder where that guy sits. It's just the same actor you saw previously. I don't want to save anything, because I live dangerously. I told you, everything is in Git. It should be in Git. And now, here's what I'm going to do. I will open up my command palette, and I will say remote containers, add development container configuration. Just bear with me. This is an extension that we installed from Microsoft called dev containers. Just search for it. It's going to change your life. Trust me on that. So once I do that, and once I wait for the internet to download itself on my machine with malwares, there we go. It will ask me for the template I want to pick. And out of these templates, you'll see that you have Ansible, and you have Azure Blockchain, and stuff like that. Ever wanted to start developing with blockchain, but didn't want to mess your computer with all that nonsense of things that you have no idea what they are? Or Azure Functions, that's a fantastic technology, but you didn't want to use or install all of that nonsense and crap? Well, you know what? You can do it. So what's happening here, I will type in DAPR, and I would urge you, when you get home, to start developing DAPR by doing it exactly like this. So the template is going to create 3 files for me. My dev container JSON, which is a configuration file. This will be named DAPR with whatever. My Docker compose file. If you're not familiar with Docker, let's talk after the session. You may have lived under a rock. And my Docker file right here, which is going to create a container with all the dependencies inside the application that I require. So you need an SDK. Do you need a CLI? Do you need Helm? Do you need Kubernetes? Do you need this and that? It's going to be inside that container. So you know what? It was previously, there was a window right here, which is no longer showing, but that's fine. I'll go here instead, and I will say, let's create this dev container. And I'll simply say, where is that guy? Come on. I'll do it one more time. Ooh, I didn't mean for that. My apologies. Where is that guy? How do I bring it up? I'll delete this one more time, and I'll do it just like that. DAPR. So look what's happening here. Reopening container is the thing I clicked. So what this guy is doing is reopening, reflushing my entire Visual Studio Code instance, and at this point, we'll install a dev container by running a docker compose up command. And once that is done, all the terminal, all the instances and whatnot are running inside a container which has all the prerequisites for me to start fiddling, working, and getting my hands dirty with DAPR. So I'm not installing anything on my machine. How cool is that? It's literally free, and it helps you a lot, because the moment you say, you know what, Alex was wrong on this one, I got to wait for the major version, you're simply going to stop that container, and that's it. That's pretty fantastic, if you ask me. So it's going to run, obviously, on a Linux environment. Here's my dev file. It's installing some fantastic pieces of whatnot. And this, see this guy right here? This is actually telling me directly from the status bar that I'm now inside a container, a dev container, with all the prerequisites for me to build, run, and develop my applications in DAPR. And that's pretty fantastic. I'm going to stop this in favor of something even better, if you ask me. So let's go back to the demos, and let me show you another fantastic piece of tech. So let's do another hand raise exercise. How many of you have heard of Kubernetes? OK, keep your hand raised if you love Kubernetes. That's always the same result I'm getting. For the reference of the recording, there was one hand up. Now, here's what I will show you. You know distributed apps, right? Distributed apps, they should be distributed by nature, right? They should run in multiple places, smaller components and services. Now, let me show you something pretty fantastic. I do love Kubernetes, and I did not raise my hand, by the way, because I don't want to admit that I like Kubernetes. It should be shameful. Here's what's happening. Let's just wait for PowerShell integrated console to load. It's only taking forever. Restore unresolved dependencies. Of course I want that. Of course I also want assets. Here's what's happening here. Inside my terminal, I will first and foremost run this apply command. The apply command will apply several YAML files. For those of you who are not familiar with this, it's a configuration file in Kubernetes. It's YAML is a subset of JSON, and what I'm doing here is that I'm instructing my application to start deploying a new deployment of 4 different microservices. One microservice does add, the other one does subtract, the other one does divide, and the other one does multiply. So you probably have guessed that this is a calculator application. Each service of the calculator is going to be an individual microservice. But the fantastic piece with it is that you might have not seen it so far, is that part of the services, every single service is written in a different technology. One is in C#, the other one is in Go, the other one is in Node, the other one is in Python. How many of you love SSL? Like really love SSL? SSL is making your life secure. You should love SSL. How many of you like maintaining or love maintaining SSL? Which means you make sure that your SSL does not expire, you make sure that it's properly implemented, you make sure that it's bound to your host names. Well, probably not a lot of people will raise their hand. And then the question becomes, how many of you love mutual SSL? Which means that you have double the burden, because the same thing has to be implemented in 2 places, so it's mutually exchanged and decreed upon your client and your service. Here's a pitch for you. Bear with me when I tell you this. DAPR can take care of all of that SSL nonsense that is making your application secure. What do I mean by that? See these 4 services, the C#, the Go, the Node, and the Python authored ones? So I will apply and I will start them. This means that I will now have pods running in my, almost there, running in my, there we go, running in my Kubernetes cluster on my machine locally. So if I try to, for example, get my pods and try to follow that information, there we go. They're still being created. Let me close this guy for a second. So subtract is now running, multiply is now running, the division is running, the calculator front end is running, which is fantastic. My add service is running. I think everything should be running now. Now, since this guy is done, here's something cool for you to see. I will get my service. For those of you not familiar with Kubernetes, a service is almost like a front end. It has an IP address or a host name, and it allows me to hook up to the services, which are API gateways, which to communicate with the outside world. In this case, I have my calculator front end, which runs on localhost. So let's open that guy up. Let's open up localhost. There we go, a calculator app. How fantastic is that? Now, this is a brand new app, and it's at 5 because I have some state for my application, by the way, and that state was 5. But this application, just as you'd imagine, does 9 times 9 equals 81 and whatever. Hopefully, it works. Now, I want to show you something else. DAPR has this command line called MTLS. What effectively this says is that DAPR is taking care of the mutual TLS authentication and security of your certificates across the cluster. See how it says that it's already enabled? I didn't have to do anything for this. The only reason for why I prepared this before is that I don't have to rely on the freaky internet, literally, which takes forever to download some container images. So let's take it a step further. DAPR also has a couple of command line interface commands that could use configurations, -K stands for Kubernetes, which says what my configuration namespace is, and here I have something called default, which does not have tracing. I can also distribute the tracing of my apps, but does have MTLS. And the MTLS workload, and this has been purposefully designed and configured by me like that, is 15 seconds. This is crazy. Let me explain you in plain, normal English. Every 15 seconds, my certificates are expiring. I'm generating a new certificate, applying it throughout the cluster for every single microservice and for every single DAPR runtime sidecar container inside my pods so that they all always have the latest certificate. Bear with me when I tell you this. When I'm looking at my components, we're going to get something similar. This application will have no downtime. It will work just like that with no problem whatsoever. And yet, when you look at my configurations and how I configured them, I can validate. So I'm doing a kubectl edit configurations default file. This is going to be a bit small. Sorry about that. I can validate that I'm using a clock skew of 5 seconds and the work as a certificate TTL of 15 seconds. So every 15 seconds, my certificates expire. Let me show you something interesting. Let's get any of these services one more time. So kubectl get pods. Kubectl, I fingered this. There we go. Let's say, for example, I want to take this pod. There we go. And I will say kubectl, and by the way, before we have an argument on this one, it's called kubectl, not control, not CTL, it's kubectl. So logs, some people murmuring around there. I'm still right. And I'm going to get my DAPR-D, my services, my container sidecar logs from that guy, DAPR-D, PRD, there we go. And these are the logs that I'm listening to. Let's do a follow. So this will listen for any changes that occur. Let's just look at this guy. Every 15 seconds, it will be notified. You have a new service that you should apply. You should install it. You should apply it. You should change it. And it's used throughout the cluster. And I can use any of the services that I want, and I can just apply and use literally anything. My application is still going to run. Why is that? Well, simply because they also have implemented retry policies, just like Martin mentioned previously, with jitter and exponential backoff, and everything nicely implemented by DAPR, so you don't have to get your hands dirty with that. How many lines of code did I write for MTLS in my code? 0. That's pretty cool if you ask me, and that literally makes distributed applications the future. So are we still developing courses? Yes. Are we ready to develop automobiles? I think we are. We're all fired up and ready to go, if you ask me. So just as a quick rehearsal, we talked about state management. We talked about how state management works. You can use your HTTP endpoints and your butlers to get your data from there. We talked about PubSub and messaging. Gonna skip that very boring slide. Get straight to actors. We talked about actors. We talked about how actors work, how you should have a placement, how DAPR has a placement service, and it automatically places all your actors throughout the cluster. So if a node goes down, no problem. The actor will exist somewhere else. The data is still available thanks to the implementation and the binding that you'd have with your state factory. You talked about how you work from a runtime or a service to invoke those actors and create those actors and maintain their data and so on. We didn't really talk about bindings, but we use a lot of bindings, and a lot of bindings are available. So if you're into Kafka or RabbitMQ or some obscure AWS TLA, I have no idea what it is, whatever. Azure Event Hubs or Cosmos DB or SignalR. If you have a requirement for storage bucket in GCP or HTTP or MQTT, MQTT or Redis, or the list just keeps on going. These exist out of the box. And the community is actively adding additional bindings, additional capabilities to DAPR because people are so interested into this. Remember, in 1900, Henry Ford made it available and affordable for everyone to buy cars. And whilst it was difficult to spot the car, only 10 years later, it was difficult to spot the horse. So human beings are reluctant to change, but mankind isn't. We want to do this as architects, as corporations, as customers and enterprises. Distributed applications will drive resiliency, will drive availability, will drive continuity of your application, and thus better optimize quality and further quality. Also, DAPR is not locking you in. You can pick any technology, any vendor you'd like. It's an open source, fully open source product. All the source code is available. There's nothing hidden. There's nothing transparent. Everything is available to you. And DAPR gives you, the developer, me, and everyone here in the room, everything that you need to have what you have probably dreamt of. The abstraction of the boilerplate code. And with that, thank you for bearing with me in my love and excitement of distributed applications. If you have any questions, I'm happy to take questions. I know there's the website. I don't see it over there, so I'm going to turn. Do you have Docker installed to run Visual Studio Code DAPR container? Yes, Docker is installed on my machine using Docker Desktop, which is, I guess, acceptable. How does DAPR handle the certificate creation and renewal? Can you use specific certificates? Yes, you can use your own certificates. You can use a certificate store. It's not yet bound to, if you're interested in Key Vault and have Key Vault generate your certificates. Key Vault is a hardware secure module service in Azure managed by Microsoft. It doesn't do that yet, but you can write it because all the APIs are available, and so are the Key Vault APIs. Is DAPR related to aka.net in any way? Well, regretfully, no. There has been a decision whether to implement the actor pattern based on Akka, based on Orleans, or any other given technology at this point. The decision was we don't want to enforce you on using a particular tech. And instead, we want to be prescriptive, meaning that we know the best practices. We will suggest the best practices. It's up to you whether you want to implement them or not. And then finally, it's possible to generate the client code to DAPR. How do you debug test? I'm not sure I follow this question. If you want to elaborate, it's possible to generate client code to DAPR. Client code to DAPR. Well, I think, and I hopefully explained that you can write the client tab, like my console applications were clients that were calling my DAPR actors and my DAPR services by invoking them. So hopefully this is answered already. How do you debug or test DAPR? Just like any other app. So here's the beauty. When I was running my applications, I was simply invoking DAPR, here's the command I want you to run. But you could simply say, DAPR, here's the command I want you to run, have DAPR run fully self-isolated and self-hosted, like I did, and then use your Visual Studio instance, Studio or Visual Studio Code, it's up to you, to attach to the running process, which is running your application, and then add the debugger and add breakpoints and line-by-line execution and so on and so forth. So that is available right now out of the box. There's no blocker. If there's no other questions, it was my pleasure to be your host for this. Oh, there's one more question. How do you troubleshoot this? How would you troubleshoot what? Troubleshoot the debugging? Well, this is a long conversation we're going to have here. Come up on stage where I'm going to have the conversation offline with you. I'm more than happy to talk to you about. And remember, stickers. So if you're into stickers, I'm happy to share them. Thank you.
Ryan.